Next here, I want to introduce you to something that might be new for a lot of you, but it's the idea of radian measure. When we measure, we have alternate systems of measurement. I can put a ruler down here and measure that as 2 inches. Or I could measure it and measure it as, I'm going to guess, about 12 centimeters. So I have units of measurement, the English standard system, or I have the metric system, and I could measure it either way. So same is true with angles. When we measure in angles, we can measure with an angle that is in degrees, or we can measure with an angle that is in radians. We have 2 ways to measure. And the radian is a little bit foreign, but once you get used to it, there's a lot of advantages. It's subtle. This is a subtle point here, and I'm not going to make a big deal out of it, but radian does not have a unit, and it makes it very convenient for mathematics and calculus and doing calculations. But that's a subtle point. Don't stress over that. But I want you to understand how to measure in radians. Now, if we take a circle and we take this side and we rotate it, and we rotate this side all the way around 360 degrees. That is like going, twisting the angle of that initial side back upon itself. So we've rotated the angle 360. But in a similar way, if we're on the circle and we walk around the edge of the circle, we've gone the entire circumference of the circle. So in a way, going around the edge of the circle is similar to turning the angle. And so there is a correlation between angle rotating of sides and walking around the edge of the circle. Now, in geometry days a long time ago, you learned a formula for the circumference of a circle. It's 2 times pi times r. Now, let's make it a little simpler, and let's just say in both situations r equals 1. So if this equals 1, then the circumference would be the number 2 pi, or about 6.28. So if this were inches, it would take us 6.28 inches to go all the way around the circle. But there is a correlation here. Going all the way around the circumference of the circle, which is 2 pi, is very similar to going all the way around the circle with the angle of 360. So we have this correlation, or this relationship here, that 360 degree rotation is like 2 pi. It's like going all the way around the edge of that circle. So when we measure radians, a lot of times we're going to measure them in terms of pi. And we can do some simplifying here. So if I divide by 2, then I've got a little simpler statement here that 180 degrees is the same as a pi. So if I measure this here, and I go to this other side, I went 180 degrees. But if I were to measure that in radians, theta would be pi radians. Now at first I'm going to say pi rad to communicate that we're talking about a different unit of measure. But eventually I'm going to take the rad off, and it's just going to be a number. And so when we measure angles, we have to distinguish between 5 degrees versus this one. So if we say theta equals 5, that's different. That is going to be understood There's no unit on it, and it's going to be understood as a radian value. But at first, I'll probably put rad here to help us keep this differentiation going. But later on, we won't do that. Okay, so so over here is the important thing to get a handle on. If I turn all the way to this side over here, that is a pi radian. But what if I divide by 2 again? Okay, so if I divide by 2 again, I'm going to get 90 degrees equals pi halves radians. So here is a pi halves. It's like a 90 degrees. Pi halves in radians is the same as 90 degrees in degrees. We can keep playing around with this and get more intuition. I hope it helps you get more intuition if I divide by 2 again. So pi halves divided by pi halves. Sorry, I said that wrong. 90 divided by 2 is 45. And pi halves divided by 2 is pi fourths. So if we do a 45-degree turn, that's this one here, it's 45 degrees, it's the same as a pi fourths angle. Going back to the drawing board there, if I started with 180 again, which equals pi, and then I divided by 3. So that's going to equal 60 is a pi thirds angle. So if I do this one right here to pi thirds, that's the same as 60 degrees. One last one. I could divide that one by 2 one more time. And that would give me 30 degrees equals pi thirds divided by 2 is pi sixths. So I've got all of these connections here between degrees and radians. So pi sixths right there is a 30-degree angle. And down below you can see all these calculations. They're showing you a one-to-one relationship on all of those different calculations. And I want to encourage you to really think deeply about this. Experiment with it. Play around with it. Trial and error, and get really comfortable with radians. Because trigonometry is much more convenient and easy for us to work in radians than it is in degrees. Now you guys, in your minds, you're more comfortable with degrees right now, but I want to encourage you to switch over. We will do problems sometimes in degrees and sometimes in radians, and you do have to be able to adapt and go back and forth. Now, in order to expand on that or help with that, I want to talk about drawing angles in radians. Now this is an extra. You don't have this in your note packet. So if you had this in class and you're just rewatching this is new. You haven't done this, but I think it's important to practice so you get a better sense of angles in radians. So where is a 2/3 angle if I were going to draw it? Well, here's a strategy that I use. And it starts with this, that I want to encourage you to be comfortable and learn that 180 degrees is the same as a pi radian. And if you start here, you can draw 180 degrees, and that can be your beginning. So if I want to draw 2 pi thirds, I would start here and draw pi. So that angle is pi. And I'm going to use this angle of pi to help me understand 2 pi thirds. Now, this is 1 whole pi. So if I write pi as a fraction, it's a whole pi. And I don't want a whole pi. I want to see a picture of 2 pi thirds. So I'm going to change pi here so that it matches the fraction I'm interested in. So a whole pi is like 3 out of 3. 3 pi out of 3 still equals 1 whole pi. So I'm changing this fraction into 3/3. A whole pi is 3 over 3. So in a sense, you can just multiply by 1. 3 over 3. And that's how I'm getting it to match this fraction in thirds. Now, 3 over 3 is too big. 3 pi thirds is too big. I need to see 2 pi thirds, this one. So what I have to do is I have to subdivide this half circle into 3 pieces. So approximately it would be 1 piece here, 1 piece here, and 1 piece here. Those are supposed to be 3 equal slices of pizza. So to get 1 whole pi, I've divided into 3 equal slices, and I want a picture of 2/3. Well, this would be 1 pi thirds. This would be 2 pi thirds. And there I see a picture right here. This angle is a picture of theta as 2 pi thirds. Well, let's try another one. So I'm going to use the same trick again. I'm going to make my circle, draw 180 degrees, which I know is pi. And I'm trying to understand what 5 pi fourths looks like. Now this fraction is not in thirds. It's in fourths. So if I have pi, I need to change it into a fraction of fourths. Well, just multiply by 4 over 4. Because 4 over 4 is 1. I haven't changed it. 4 over 4, 4 pi fourths still equals pi. So this drawing that I have right here is 4 pi over 4. And it helps me visualize what 4 pi fourths is. And I also know that 4 pi fourths is too small, because I want to see 5 pi fourths. Okay, so I know this angle that I've drawn so far is not big enough. I have to go a little further around the circle. But in order to know how much more do I add on, I've got to add on some more, and I don't know how much to add. Well, let's go backwards. Let's subdivide this 180 degrees, which is 4 pi fourths, into 4 pieces. 1, 2, 3. So I've taken the pizza this time, that half pizza, and I've subdivided into 4 equal parts. So this would be pi fourths, 2 pi fourths, 3 pi fourths, and 4 pi fourths. Now the reason I need that is because I want to know what is 1 pi fourth. Because 4 pi fourths was too small, I need to add plus 1 more pi fourths. And over here I see how big it is. So I'm going to add this piece down here. And so 4 pi fourths plus 1 more pi fourths will give me 5 pi fourths. And so now I see what the picture of 5 pi fourths looks like. It looks like an angle that's that big. All right, here's one more drawing we'll do just to help you get the idea. I encourage you maybe to go back and try these with yourself without looking. Draw each one of these again. Let's do 10 pi sixths. Okay, so I'm going to start again with this starting point every time of pi. And now I want to relate pi to this angle that I want to draw it and see what it looks like. Well, this angle is in terms of 6, so I'm going to take my pi and make it in a fraction of 6. 6 pi over 6 is 1 whole pi, so it's still 1 whole pi, but now it's a fraction of sixths, and I'm realizing that 6 pi sixths is way too small for 10 pi sixths. Okay, so I got to go further. But the question is, how much further? That much? That much? Where do I stop? So I don't know yet. So let's back up and get some more numbers here. Let's cut it in half. Now if I cut it in half, 6 pi sixths going back half, that would make this 3 pi sixths. And then if I divided this, that would be 2 pi sixths, 1 pi sixth. So there is 1 pi sixth, 2 pi sixths, 3 pi sixths. So I'm trying to get up to 10 pi sixths. Well, here's 3 pi sixths. So if I add 3 pi over 6, it's a 90-degree turn. So right there takes me to 9 pi over 6. So if I add that, I'm almost there. Still 9 pi sixth is too small. I need to go a little bit more. I need to add 1 more pi. If I add 1 more pi sixths, then I'll have 10 pi over 6. So this is the size of it right here. So I'm going to add that little piece right here, and that will get me to my angle of 10 pi sixths. So that drawing there is a drawing of an angle that is approximately 10 pi sixths. So now I have a better sense of visualizing these angles. I'm going to adjust this one back here because this one landed back. So we actually stopped here for the 2 pi thirds. Now I haven't talked about this yet, but I might as well throw it out there. When we talk about thetas, we also talk about their terminal side. This one is in quadrant 2. And this one is in quadrant 3. And this one is in quadrant 4. There'll be more on this later, but that's important to identify angles in their quadrants. The quadrant is because it ended in quadrant 4, and this one ended, the terminal side ended in quadrant 3, and that terminal side ended in quadrant 2. Okay, so a little bit more practice on this. So now I want to connect in drawings and converting. So we're going to draw and convert into radians or radians into degrees. So let's draw 120 degrees. All right, so degrees are a little easier. If I turn this much, that's 90, not enough. 120 minus 90 is 30. So a 30 is about like a third of 90, so I've got to go about that much more. So that is roughly 120 degrees. Okay, now we also want to convert. Okay, so 120 degrees. We have these conversion ratios. And if we were in class, I would ask you for these different colors. The black one is 180 degrees over pi. And the red one will be pi over 180. And you have to choose one or the other to make the conversion. Now, if you study the book uses this formula here, and they use proportions to solve it. And if you really love the book's use of proportions to convert, I encourage you to do that. But I'm going to stick with these conversion ratios because in physics, when you do dimensional analysis and you convert units, it's more like what I'm doing with these multipliers. So it's pretty consistent with other types of unit conversions that you do. So I have 120 degrees. Which one do I need? The black one or the red one? Well, I need degrees to go away. So I'm going to multiply it by pi over 180 degrees. So the degree on the bottom will cancel that degree on the top. Now, sometimes the fractions are easy. We can easily see that 10s cancel. We got 12 pi over 18. But we can reduce a little bit more because 6 goes into both of those. So we're going to have 2 pi thirds. Now I want you to stick with an exact answer. This is exact. Don't go into the calculator and give me a decimal, because as soon as you put pi in your calculator and get a decimal, you do not have an exact answer anymore. It's a round off, it's an approximation, it's lost its exactness. So for our radians, whenever possible, we want them in terms of pi, because that keeps the answer exact. Let's jump down to 280. Let's draw that one. So 280. Well, if we did this, this would be 90. This would be 180. This one is 270. It's not enough. So I need 280. So this is 270. I'm going to have to go 10 degrees more. So that little piece there is 10 beyond the 270. So that's a picture of 280. So 280 degrees, I want to convert that. It's degrees. I don't want degrees anymore. So that means the red one over here will convert pi over 180 degrees. So the degree unit on the bottom cancels the degree unit on the top. And I don't have any units anymore. And so it's a radian value. Now immediately I can see the tens cancel. If you're good with fractions, you might also see that it's reducible by not 10 but 20. But some of you aren't as good with fractions. I'm going to go slower on that. So I cancel the tens to over each other, and then I can see 2 goes into both of these. So I'm going to have 19 pi over 9. That's 18, double checking my math. No, it's not 19. 2 goes in 28, 14 pi over 9. There's my exact value. Okay, let's do it the other way. First, let's draw here. So, 7 pi sixths. If I were going to draw 7 pi sixths, I would start here with a circle, which is pi. Now I need to relate pi to this fraction. So I'm going to make one whole pi into a fraction of sixths. So that's 6 pi over sixths. That's not big enough. To get to 7 pi sixths, I got to go a little further. Well, this is 3 pi sixths. And that would be 2 and 1 pi sixth. So now I see 1 pi sixth is this little piece. So I'm going to add that little piece here. And that takes me to 7 pi sixths. So there's my drawing of a 7 pi sixth angle. Next, I want to convert it. Okay, so I need a conversion unit that will multiply and cancel radians and leave me with... Wrong, I didn't do good color schemes here. I'm going to make this one purple. So I need a conversion unit, 180 degrees over pi, and you can probably anticipate, since I'm changing it there, that I need the purple one. Because once I've canceled the pi's, I'm going to have only degrees left. Now, if you're not good with fractions, you're going to have to play around with the calculator, and you can type in 7 divided by 6 times 180 and go to the math button and type in the first command, which will convert this to fraction. So you're going to have to work at a little extra with the calculator so you can get these fraction calculations done correctly. But hopefully with more practice, your intuition will start getting better and you'll get better with the fractions. And some things I'm seeing here is 6 goes into 180 30 times. And the pi is already canceled. So all that's left when I multiply is, oh, by the way, when I divide by 6, I have 1 in the bottom. So it is 7 times 30, which is 210 over 1. I don't need the 1 anymore, of course, because that's all reduced. And the degrees are left, so it's 210 degrees. So we just converted it. 7 pi 6 is the same as 210 degrees. One last one. Let's draw it. Here is pi. Okay, now I need to relate pi in terms of 12 so I can see what I'm looking at. Well, 1 whole pi is 12 over 12 pi. And that's clearly not enough. It's not big enough to make 19 pi 12ths. So, how much more do I go? A little bit or a lot? I don't know. So I'm going to back up a little bit and look at some smaller values here, like halfway. From 12, that would make this 6 pi over 12. And that would make this 3 pi over 12, and I'd have to cut that 3 pi down into 3 more slices. 1, 2. So right here is 1 pi 12ths. It's really tiny. But I'm trying to get up to 19. So if I take this is 90 right here. So if I add that and go all the way around, that's like adding 6 pi 12ths. So that's going to be 18 pi 12ths. Wow, I'm really close, but I don't have the 19 yet. I need one more. So if I add this little piece here, that one more piece, 18 pi 12ths plus 1 more pi 12ths will give me 19 pi 12ths. So this angle here is what 19 pi 12ths looks like. All right, so we got a drawing of it. Let's convert it. Lastly, 19 pi over 12. And I want the radians to go away and have degrees left. Well, that would be the purple one again. And I'm just going to do some fraction math here. And I can see that the pi's cancel. And it turns out that if we take 180 and divide it by 12, it turns out it doesn't go in perfectly. But I could divide by 6. So if I divide by 6, I get 2. And if I divide by 6, I get 30. And so 30, if I start multiplying 30 times 19, 30, I messed it up. Now it's degrees, and then finally divide that by, I'm going to get 285 degrees. And that kind of matches with the drawing because 270 is 3/4 of a circle. And so we went a little past 270 for the 19 pi 12ths. Okay, so this is just helping you connect the idea between degree and radian. And I want to encourage you to draw radians and get used to them so you can visualize radians. Okay, keep studying that. I have a couple of practical examples and formulas for you coming next.